Hi, I'm Brian Yaeger. I'm here from the service organization. I represent the Spectrum Scale core team, protocols, and originally ESS, which is now moving into a separate support group, but we're still involved. Where's the clicker? Okay, so I know I have on the chart here best practices in the field, problem avoidance, but I just want to cover a little bit about our support group and what we've done over the course of the last few years. And then I want to get into a little bit of our classification of the top problem categories, and that's orthogonal problem classification I'll get into. And then the bulk of the presentation will be the service best practices, and I'll cover a bunch of scenarios there. So one of the major areas of improvement, we're now doing a real follow the sun. This has been a big expansion on the team in Beijing. We originally, a few years ago, we only had a group in Poughkeepsie, New York, and we'd have a lot of call-outs in the middle of the night. We have this goal of 2-hour response time. Advertised. We have internally a 1-hour response time for those severity 1 system down situations, but we really didn't have a group in support in the right time zone for customers. So that's been a big change for us over the past few years. We've been building that team. So that team is experienced staff. We didn't bring them off the street. They have skill in the product already. There's been improved response time we've already seen from that team, and of course a positive impact for even the severity 2, 3, and 4 PMRs, the non-system down severity ones where they're just in the same time zone. We're also staffing that team to have live queue coverage between the Poughkeepsie, New York team and the Beijing team. The full 12 hours on each side so that you're going to have a live person when necessary. So that really cuts down that call-out period where level 1 has to reach somebody. And then we have additional improvements coming in 2017 outside of that Beijing team. So I'm not talking about what happened in ESS support at all here, but the ESS support team is also a worldwide team, and that is still rolling out. We have that in the US and Canada, and the rest of the team is still phasing in. They have level 2 set up, but level 1 is not yet engaged for ESS worldwide. So these are our locations. We have the Poughkeepsie, New York location. We also have some folks in Toronto, Canada, and then the other large group is in Beijing, China. And of course, if you have any, management, issues that you are calling in off shift, right? You're going to get a duty manager, but these are really the managers that are dealing with the day-to-day. So we have Bob Raganese for the Poughkeepsie and Canada level 1 manager, Junhu for Beijing, and then we have Wenwei, our second level, and Andrew Giblon's here today with us as well. But so you can always reach out to them. If you call in and request for a duty manager, you're going to get not necessarily one of the support managers from our specific group. So it's always good to be aware of those directly involved. Back to problem areas. So this is really the bulk of where I wanted to take the presentation for problem avoidance. I had actually made these charts for another presentation that was requested of me. There's an individual who looks at this information from IBM in terms of trying to figure out where we can focus, right? And this is called OPC, Orthogonal Problem Classification. It's something that was developed from IBM in the 80s. They used it for defect analysis, and eventually we came up with this tool for the support team as well for problem analysis of PMRs. This tool, I have to have a disclaimer about this information though, because the tool for problem classification allows the individual level 2 support engineer to look at the information in the PMR, working the PMR, and choose categories and also create their own categories. So we came up with these categories that we felt would best represent the information as a whole from the leadership team, and individuals will interpret those categories differently and also add their own categories. So there is some overlap. The idea behind orthogonal problem classification was that each category was supposed to be statistically independent of the other categories. And we don't always have that here. So you'll see some overlap, like the cluster management, the top problem category we see, and then we have the not spectrum scale category. I'll break down these into a little bit more detail.
So Brian, how can you have a category of not enough data? That doesn't seem quite right to me.
Yeah, so this is a high-level category, right? When somebody is trying to classify what went wrong in a PMR, the engineer would say, I don't really have enough information to classify this problem because the customer decided they didn't want to pursue the problem, or it wasn't possible to collect traces at the failure event hours ago.
So I know that I have PMRs that I end up having to close it because I can't get traces. I only occurred once in a blue moon. So, but I don't think that should be a not enough data classification. I think that should be a NMFSD classification. Just because I can't get the data doesn't mean there's not a problem. It's obviously a problem. I just can't get to the traces.
Right.
So it's a data collection issue, not really can't get you enough data.
Yeah. You'll see in the next slides, we also have not spectrum scale overlapping underneath cluster management. So the high-level category, the goal was that you would be able to focus the problem into a specific group and component where we develop it in the product, and then from there we'll break down further. I don't know, Bob, did you want to comment at all on that?
Yeah, no, I agree that the not enough data in this top level category should be a lot smaller. But what we did was, through cluster management, the MFSD and all that, we also have not enough data. So the goal was that those were the ones for the focus should be on. So we agree.
Yeah. So that's why I was trying to say statistically independent is not happening here. So that's my disclaimer. I wanted to give you this, and the individual engineers are still choosing and putting things into categories where they may not give us the best information. And this is not the full view of every aspect of what we're collecting with OPC. This is only the top level category. We also collect information about how long outages are, what the impact is to the customer, the environment, and whether there's other software at play. So let me just go into the breakdown of the top 5 categories a little bit. I have some pie charts here.
So just a quick comment. So it's great that the engineers try to categorize it, because I can understand in your organization you need to know where to steer it. But as a customer, I have a perception of where the problem is coming from. And I think you need to capture that as well, because that's really what you need to address. My perception, not necessarily the reality. Either fix it so that I don't have that perception, or educate me so I know what category to really put it in.
So you're saying you'd like to have us survey at the beginning of the PMR, at the end of the PMR, from you to see where you feel?
Or I could tell you what I think it is.
Great feedback.
It's a positive closure, so
yeah. Thank you. So in terms of cluster management, this is the second level category that we broke it down into. Install update issues, administration, expel, or lost members, configurational issues. So these are representing, at the high level here, we're still talking about Q&A issues or defect issues, or problems that aren't necessarily in the product could still fall into this category depending on what the level 2 engineer had chosen. But then you can see here in the MMFSD daemon, you have a second level category of not spectrum scale again, and not enough data again. And this is where we would hope that the path would be taken with the OPC collection tool. So we would say, okay, here you had a problem with the core of the daemon. Was it something that you couldn't gather the data, or was it really something you were able to tell if it was specific to another software product?
So on MMFSD, you have like performance and assert. How many of those actually turn into like defects? Do you have that? Do you have a percentage of all of that ends up being a defect versus just a Q&A?
We do have those percentages, but I don't have them part of the charts here. I have, there's actually another individual whose role it is to analyze this data. He has very extensive information on it, and I just wanted to give a quick high-level overview here. But it's go ahead.
I wanted to ask a question. I don't understand under cluster management. I see install and update. I presume that's the initial install. Data administration and config. I'm a little unclear. Can you talk about this?
Sure. So the install and update is the initial deployment, or reinstalling a node, something like that. But administration, we would count those as various commands. So let's say you're trying to migrate data from one storage pool to another with an MMApply policy. We would consider that like an administration type thing, whether you have the correct policy in that command. It's going to include, ILM, but it's not just that example. Pretty much any MM command that you're running to make a change in the cluster, adding disks, removing disks, might fall into this category too, although we have a separate NSD specific category. But it's really supposed to capture what was the initial problem report in the top level category was, am I doing something to my cluster? Or does it have to do with a node joining, leaving, adding, removing, anything like that? And configuration. So these are going to be just mmchconfig type options. Also, depending on what the L2 engineer chose, they might end up putting something in here for a misconfiguration type problem where it's not a supported configuration. That they might sneak in performance type tuning parameters in here, although we have a separate category for that. So there is a lot of room for error depending on what was chosen. So.
And his message, is that like RPC communication on the manifest?
Message. So this one is also, I would say this one would be, is there a problem with, I received the observation that a message came out in the MMFS log on the console. So it could include something from a daemon message. It could include something I ran a command, and that's the result back was not what I expected. It could also include a user that was happening to use the file system. Got an error trying to access a file. So it's very open at this level. These are the high-level categories, and we break them down further beyond this, but very generic at this level. Any more questions on these top two categories? Okay. Okay, so here you see the not spectrum scale category, and this is something that we actually hear often and we see often in terms of support. Somebody reports a problem, and we're looking at it. It's a hang or a deadlock or performance issue, and we're able to diagnose it down to another product, another software, an operating system level problem, or a network problem. The storage, interestingly enough, so this is all data coming in from 2016, but when we were in the, probably before the introduction of protocols, all the deadlock amelioration changes, we were seeing a lot more in the storage category, whether you're seeing something hang or you have a dead man switch timeout. But now we're starting to see more of a balance across some other categories. I think the message here really that I get from this chart is what can we do with the product to make it more obvious to you that there's a problem, outside of spectrum scale. How can we monitor and make sure that my system, my cluster is healthy, and it's not just spectrum scale itself is healthy, and things underneath or things that we rely on above or below us are not doing so well. So there's been a lot of improvements, I think, from this information that we've been passing back. We have regular meetings with the development team on what could be done from a service and reliability and serviceability perspective with the product. And I think over the course of the last few years, I've been seeing a lot coming out there. The MM Health, the GUI now makes it, you can get alerts and things like that. A lot of changes where we're tracking things that we weren't previously that really have to do with other areas of the cluster. And a big one for us, and that not enough data category used to be a lot larger, by the way, is deadlock amelioration, and what we could do to capture that data when the deadlock's happening and not make it painful to say, oh, you've already restarted your cluster, we can't get to root cause now. So that's a real big improvement we've seen, and we continue to pass back that information.
So Brian, and one of the things that I continue to run across is when I'm getting into a unhealthy cluster situation is traces, and need to enable traces to get the data that you guys need. Now, I can't, or I feel I should be using enable 24/7 on all of my nodes. Although I've gotten some feedback from Sven and others that might not be as bad of a thing, at least a small trace buffer might not be as bad of a thing. And so, I don't know, maybe we can talk about this later, but tracing being enabled and being able to, if it happens once and I don't see it again for 6 months, then I'm tracing enabled, I'm dead, because you'll be able to go up your hand and say, well, I can't tell that I don't have the trace.
Yeah, there was some effort to improve tracing. I mean, there were a lot of, initially when somebody would start mmtrace on a Linux machine, it would create a huge impact in performance, and that we've seen get better. But some ideas thrown around was like a light level of tracing. And in order to have something useful without impacting the cluster running all the time, that's been one hope for us, passing back that message from service, because you could have a problem that happened and caused an inode to be in a certain state, but it was hours ago, and how could we get that information? So the light level of tracing was one direction we were hoping for, and in terms of capturing that data when there is a problem that is, at the moment of failure, that we're actually getting with a lot more with the deadlock amelioration. Also for expels, we're capturing both trace, internal dump data, but we're not there yet with tracing all the time. There's a lot of things that, in terms of finding out why something happened hours ago, even if we had that light level, you wouldn't be able to get to it anyway.
So I've had the experience from a bunch of my customers coming to me, and yes, GPFS or Spectrum Scope would be a canary in a coal mine, totally different. But if there were configurable threshold parameters, you could do an MMCH config that when they are exceeded, maybe at is some type of a delta, that would be very advantageous from a data collection perspective.
Yeah, so the deadlock amelioration is configurable with timers today.
I mean that in a broader sense.
Sure. So the question I think was if there was a way to configure a parameter that would capture data when a waiter was of a certain length, that would be helpful. So right now, there are timers to detect overload situations where I/O is taking right now, I think the default is 5 seconds, and then also deadlocks when we're seeing waiters of certain kinds that exceed 300 or 600 seconds. That's in the product today and is available and would capture internal dumps and.
Yeah, but I think what you're getting at is it'd be nice to say my I/O waiter shouldn't be more than 20 seconds. That's pretty bad. And so if I get 20 seconds later, I can collecting trace, just dump it out and restarting the demon and killing everything else off. So I have like half of the data. Like these
And waiters is just one example, right?
it would just yeah.
There, you could be also monitoring TCP statistics that when all of this sudden you see a ton of retransmissions, you say, I want to collect this information.
So some kind of hook that says, collect the data that the deadlock code will collect, but don't require a deadlock of the triggers. So I can basically set a threshold based on network specific retransmission, whatever I want, and poke the GPFS and say, dump this stuff.
Yeah, and if you could like, and I know that's asking a lot, right? Because it's not just GPFS now that you're needing to monitor, but that helps you to narrow the time to resolution. Because if you're trying to find out, why do I get to this funky waiter every now and again? It turns out to be a network uplink on a switch that's seldom used, that one of your clients just happens to be hanging on, that's flapping. Getting to that takes a lot of time if you don't have to do that.
Right. It would also be really nice if you could configure something like a limit of collections to take place so you don't end up with a risk of delaying some of the deadlock detection and a cascading failure or a loop of collect. You can say, let it happen at least at most 2 times and then stop collecting, just disable it, try to recover.
It does that today. The deadlock goes on.
The default is 10 times today.
Sorry.
But I don't think that today that it makes any differentiation between a deadlock or delay in terms of IOs and something network related. It's just going to be 10 times a day, whatever it is that it detected.
Question on the non-spectrum scale pie over there.
Sure.
Who owns all of those ones, right? Because from a spectrum scale perspective, you can say, oh, the network, awesome, not our problem, right?
Sure.
But from a customer perspective, we bought the network from IBM. And the OS, oh good, non-spectrum scale, well, that's the Linux Technology Center, which also happens to be IBM. And the storage is our ESS that we got from IBM, right? So who owns the cross-cutting of the non-spectrum scale issues to make sure that they still get run to ground?
Right, so the question was, in terms of the not spectrum scale category, who owns getting those problems to resolution? And if they are all IBM, how do we get support down to the right level with opening the PMR right to spectrum scale? And today, we are a component level support team for spectrum scale. So what that means is if you open up a PMR to us and we determine the problem is outside of spectrum scale and we have a clue as to where the problem is, we suspect it's an OS level problem or a network problem, then we're going to try to get you to that team. Most of the time what the support team will do is they will probe the customer first. Are you running support with Red Hat directly, or if you have Ubuntu or whatever operating system you have, are you engaged directly with them, or are you a customer of IBM, and can we engage that team for you? Same thing for disks or hardware. The only exception is we don't have a process in place to necessarily always get you to the right hardware team. And that's a little bit about the way the hardware support teams are structured worldwide. There are separate hardware teams for each country, which is different from the way software support runs, where we have a single support team globally that can handle all the issues. So a lot of times you'll get a request back from support saying, could you please open the hardware ticket? Now that's different with the solutions like ESS, where we know that it's all IBM, or we know that we can just get you to write to this hardware team. But we're trying to improve there too. So we have set up recently the ability to engage Power Hardware Team directly. And we also are looking to find ways to engage other vendors as well. Like since the divestiture of System X to Lenovo, they're no longer in the PMR system with Retain and IBM, and we don't have a way to just transfer tickets between them directly. So we have the system they're using where we're able to engage them through a Salesforce ticket. And that's something that we're hoping to smooth over and continue to have meetings with them on. So long answer short, at this point, we do our due diligence to try to get you to the right area. If there's a case where we don't know, right? Like, so you have a problem with performance on your storage, and we just see in the cluster that I/O is running slower. We don't really know if the problem is an HBA, it's a server load issue. You know, we have to do the diagnosis, basically, go down the levels, and could it be a problem on the SAN or a lower level beyond that? We don't know. We will try to get you as close as we can. But managing the problem from top to bottom and staying with you is not something that we're doing at the component level. That happens at the solution level. File system and not spectrum scale here. These are two more of the top 5 categories I wanted to break down. But again, with file system, you have the mount and unmount, ACLs and file system corruption. We've found that a lot of these mount-unmount issues are really misclassified. A lot of times they end up, the tertiary classification ends up pointing back to problems that are either configurational or go back to either not spectrum scale issues or just an understanding of the cases where the product is actually supposed to mount or unmount, like an expel. So there is some, again, overlap here. I think the main message I was trying to put across with showing these top 5 categories was that a lot of them have to do with not necessarily problems or defects in the product, but how you observe problems happening in your cluster. So what I wanted to talk about really was some examples, some scenarios that I came up with that I see all the time. Some of them are simple and not so great necessarily for the more experienced folks in the room, but are really what I would say best practices to avoid those problems. So before I jump off of these top 5 categories, any more questions on this last one? No? Okay. Okay, so this is really a simple one. It's really amazing, but we get a lot of these type of issues, and in terms of upgrading my cluster, you know, I just, customers sometimes they come to us and they say, you know, XYZ wasn't working, so I just upgraded everything, installed everything to the latest levels. Not always a good idea. So you don't want to just yum update -y, get all the latest kernel levels without making sure that they're all compatible across the board. Depending on your other products, there's other places you need to check, but usually not a good idea. So just a real simple one. Everybody can gloss over this. But here's a common one. Spectrum scale, we get these a lot, the disk level issues where it just can't find the NSDs. You know, something happened where, you know, I can't mount my file system anymore. I've upgraded my operating system. I've made a change in my storage. I've done firmware updates, and all of a sudden some disks are missing, or my file system won't mount, too many disks unavailable messages. So really the best practice here, I'd have to say, is just make sure you know, you're not ever putting your disks at risk. So what I would like to suggest is that customers isolate those disks from the NSD nodes. If you're messing with your NSD nodes, don't make them available for other software to mess them up and overwrite them. So isolate them, whether you do that at the SAN or the controller, or you just find a way with multipath to hide them from the system. Just make sure that you don't give a chance for those issues to happen. One of the things that we did see a lot for a while, unfortunately, was during a Linux operating system upgrade. Back before the NSD version 2 format, it was pretty easy because there was nothing really to prevent you from going through the installation and recognizing that you're overwriting your disk. Let me just install my operating system across all the disks that are available, including all the SAN attached disks, and overwrite everything and lose my data. So that was a great improvement. We have that V2 format in 4.1 and the GUID GPT on the disks. But one thing to keep in mind is that if you want that GPT on there, you have to make sure that you're migrated your minimum release level on your file system, and you've done your mmchconfig release equals latest, and you do your change on your actual file system format on disk. That's something we see missed a lot across the clusters. You know, we're migrating, customers are migrating node at a time, and they say, okay, eventually when I have this cluster and this other cluster, everything's at the latest level, then I'll go back and update to the latest release. But then they never go back.
So one thing that I have some file systems that are really old level, and in order for me to get up to that level, I have to do a fast EA conversion, and that's something that I can do online, and it shouldn't impact me at all.
Yeah, I mean, depending on what level and
It's
features.
probably started out at, I think it's probably a 3.5 level or something or other. I don't know.
Yeah, I think I'd have to go back and check specifically on.
Because you can't bump them up to the latest levels until you do the fast EA.
Yeah, there was an online, there was a quick offline, but I'm having a hard time remembering back to the earlier levels specifically. But we could look into that for you. So I just have a couple links I'll throw in the presentation throughout this, so you guys can reference if you want. So another area we occasionally see is changing device type. Say if you've moved from one type of disk vendor to another type, you're using a different device type in terms of power path versus generic. This is pretty well hidden in documentation and can cause all of your disks to appear to be missing. Or even you have a really old NSD device's user exit installed. We'll see those occasionally hiding the disks from GPFS, and people just aren't aware that they're there and need to be updated with allowing GPFS to see those disks again. So I just wanted to throw in a few helpful commands if you ever run into a situation where you think you've lost your disks, or GPFS isn't seeing the disks, you have a disk in a down status, or LSNSD shows not found. One of the the diagnostic tools we use is MMFS-ADM test read desk raw, which stands for read descriptor raw. That'll let you see the internals of what's written on the disk in terms of file system descriptor, NSD descriptor. It'll even show you if you've done a MMDEL NSD for an old disk, we actually clear it out. It tells you the time and the node IP address when you've cleared it out. So it's helpful if you're ever in a DR environment. TS prepare disk commands here. These are a good way to see if you can read the NSD ID across the disks that one node is able to see. And then if you're finding a situation where AIX, for example, you're not seeing anything with TS prepare disk-s, it might be because we're not seeing it from the operating system level. So these are some good tools to just see what's going on from the perspective of, is anything on the disks, or is the operating system just not exposing the disks to us? Multipath is a good one if you're running with multipath, just to make sure that those are configured and showing. And then there's a SCSI command, SGINQ, I threw in there. Sometimes if you have a mapping issue and you want to see down to the specific disk level whether that WWID is really there. And then systool is a nice one. Also not typically installed on Linux, but I like that one for figuring out whether things are mapped properly from the SAN. But these ones in particular, you can just check out for the most part in the man pages. They're pretty helpful. The only one on here that I would say, in terms of these TS commands and the MMFS-ADM test commands, there's not much risk in running these at all. They're just, read-only information, but these are not officially documented or fully supported in terms of, if you're curious about the different fields in these that you're getting and seeing in these commands. So they're not externalized to the point where it's easy to understand all the output.
Right. On that, the raw descriptor first, if you capture that information and then you had an OS over at the beginning of a very large one, would you be able to pause what I need to be able to try at least to put that descriptor back and get you the rest of your 8 terabytes?
There is ways. So the TS prepare disk does have a way to write back NSD IDs, but in terms of the full output from a read descriptor raw, I don't think that you would be able to get that information necessarily from the file system descriptor output there. I think you'd rather just collect a short DD of the
I
beginning
have
of the
been in
disk.
this situation before where NSDs have been duped by an OS install, and yes, with some surgery to the disk, it's possible to probably recover it. You have to know a lot about who's got the most recent version of things.
Yeah, that's the trick, and that's why I said no initially to the question if you had the information from this output, could you go back? And it depends on whether you have a file system descriptor and how old that file system descriptor is on another disk that didn't get overwritten, because we need to copy that data, that descriptor, from another disk and put it back on this disk, and just this command output alone wouldn't be enough. So a DD, a short DD capturing that bit would be the best thing to save.
Yeah. I guess my one comment is, given the somewhat common this is, it would be nice if PPFS started doing some preventative or protective types of saving of that information.
It's actually, if you overwrite the NSD ID on a disk while GPFS is running, it will now go back and write it. And you'll get a message in the MMFS log. So that's another one of the key things we got from the service team feedback. Okay, this is just quick recovery, things to try. I like to point this out. This is more relevant for FPO clusters. MMCH disk start MMCH-A is not the same as MMCH disk start with a specific list of disks. There are cases where you might have multiple disks that are down, and this happens more in an FPO share nothing cluster environment where multiple nodes went down at the same time, and you see multiple disks down. Maybe you have one machine that's going some sort of hardware failure and can't be brought back up, but the other machine is available, and the disks won't start with the CH disk-A. Try the MMCH disk with just the node whose disks are available that you want to bring up. A lot of times this will allow the system to recover, the cluster to recover that file system. So sometimes we see these as a call-out type situation, and that's a great thing to try. So cluster is expelling nodes, and you've lost quorum. So we see these quite a bit too. I think this falls into the cluster management category. So some of the things we see often, mismatched MTU sizes, so switch isn't configured properly, I'm getting dropped packets, and then of course the firewalls get enabled, somebody thought they disabled it and it's running again, or it's ephemeral ports are somehow getting blocked. We have clusters where there's really old levels of OFED on some nodes, and then the other nodes have been migrated to the latest levels, and they're seeing issues between the stack there in terms of the network. It's nice to see, and it's not necessarily always causing a problem, but it's nice to see consistent levels across the firmware on the machines. So,
I know that there are the guidelines when you set up a server to be an NSD server, you're supposed to do all these steps. Would it be possible to put in this MMFS daemon, oh, I see you have SE Linux enabled. You should really turn that off before you let me start. And rather than let it actually get up and running and start destroying the rest of the cluster.
Yeah, that's great feedback. There's more and more things like that we're trying to introduce into the product. There are some now messages that are starting to come out when it first starts up, you might have noticed, than there used to be, but there are things like that that we're hoping and maybe we'll touch upon with the Health presentation. So the other thing here I wanted to point out, OS-specific TCP and memory tuning and configuration. Sometimes these seem to be forgotten when a node gets reinstalled, or just forgotten altogether. And I'm sure you've seen that our recommendations on where these sysctl.conf settings, if you're just using the ones that we have in the manuals, have changed over the course of the years. We're starting to put those out on the FAQ more, and we're putting them out also on the DeveloperWorks wiki.
I'll say it again, DeveloperWorks wiki many times has wrong and out-of-date information. There's a lot of pages out there that are just like 2 or 3 releases old, and it's not really specific. So I want to again encourage you guys to make sure that what's out there is really the right stuff, because I think Linux has changed over the years, Scale has changed over the years, and I don't know if a lot of those parameters are really, and now you guys are doing self-tuning on a lot of stuff, and so it's like, do you do those things or not?
Right. So I'll make my comment that I always make about the wiki. And I had a conversation with somebody earlier. I'll suggest this. The comments don't generate emails to me and the other people that manage the wiki, and it's on demand. So what I'm asking for is maybe that we'll try this. If you see something and you say this doesn't look right, but you don't have time to research it, you don't know the answer, square brackets just put in there, I think this has changed in this release, and I'll see that change, and then we'll try to address it. Because the wiki is literally a community wiki, it's on demand.
Yeah, but you guys shouldn't be pointing people to the wiki, even if it's community, if you're not going to stand behind the information. I'm just saying.
No, I understand what you're saying. The trade-off was this, right? Either we put less information out because it takes more work to put it out,
or we put more information out there and some of it's not going to be right or useful?
I would say that bad information is worse than no information.
That could be.
Okay. Enough said.
Quick one on that, on the tuning front, we are trying to consolidate some of that tuning that's out there. You're right, definitely there's out-of-date stuff on the wiki. We're trying to fix that stuff, and it works hard on that. One thing I always use, I just look at the last update on any page. If something has been updated since 2010, it's a good chance it's outdated.
So that's an important distinction, particularly as it relates to the user group. A couple of years ago, somebody did a presentation on tuning clients, and I had a customer blindly use that information without context. And he made his worker one for 1,024 of 256 clients. So I think maybe for those, probably need to go back, add a caution sign or something.
Yeah, that's right. So Scott maintains those tuning pages. I know on the shared nothing cluster of the MDO side, we're looking at that in the cloud team because that's where our storage. Our storage in the cloud is really shared nothing right now, so you want to see this. So we tried to look at all the tuning recommendations that were out there. There are a lot of them I realized. We tried to consolidate those and get a few people in development to look at them and sort of sign off on them. So we're aware of the problem. We're trying to take steps to fix it.
From the service side, we're also rolling out a new tool in terms of knowledge management. There's a tool in IBM that we can basically maintain documents internally and externally. The knowledge management knowledge center would be linkable to customers, and those have a review process. So when they get aged, they go back to the reviewers and they either expire. They also include what releases they're applicable to. And that's an initiative that I'm leading in the service team to try to get more documents into that tool that we can link you guys to and know whether it's applicable or not to.
Would it be possible in the wiki to have some amount of applicability information at the top of the article that says this was developed under GPFS version whatever, and maybe even some big gotchas like if this or this or this had changed, then it's definitely not time to try to use this information anymore.
There is an effort, but I will admit freely it is inconsistent. Because it literally comes to how we interact. If I run into it at a customer site, I actually update the wiki all the time at customer sites and try to give that context. Oh shoot, this changed in 3.5 and so on. But it's ad hoc.
Okay.
All right. So this is another best practice. I don't think I'm going to be able to cover everything here, but I think you'll see this in a later presentation. Don't just add a node back into the cluster without doing any checks, right? We have this great tool now, MMNet Verify, that can do a lot of great things, basically, to prevent you from seeing expels. One of the things that we'll see is when an NSD quorum manager node gets introduced back into the cluster, it's got priority over the other nodes in the cluster in terms of which one gets kicked out when there's a problem and the cluster manager can connect to both. So what I recommend, first just try to do your due diligence, make sure that it's reachable. If you don't have the latest 422 level and the ability to try this MMNet Verify, do some things with Nmap, verify the ports, or even as simple as a telnet, just to make sure that you're able to get through. Between all the nodes in the cluster. And the other thing is take your quorum and manager node responsibilities away from that node before you start it up. So make sure it can join the cluster, you're able to mount the file system, but don't give it those responsibilities again until you're comfortable that it's working. Once it's working, then you can dynamically re-enable those. Another one we see missed fairly often is the ring buffers on the network adapters. This can really help out with bursts of traffic coming in. We like to see those bumped up. You'll see those bumped up automatically in the solution environments like ESS already. So this can help avoid some of those expel type situations or packet loss. And this is just some general recommendations and a link to it. By default, they're usually only 256, so they can make a difference with these.
One thing that helped me out in recognizing expelled nodes is there's a script you can put in var, ms, etc. that's in the samples directory, and the expel node script that'll get run every time you put it on your cluster manager nodes. And if you can like, I had to blog an event to a chat room or something like that, so when the node gets expelled, you can tell.
Yeah, we actually have some.
Expel should be a relatively frequent occurrence, right? So.
Yeah. So there is some automated data capture with expels now. We also have some more, other than the sample you see shipped with the product for expels. We have some level 2 written scripts if you want to open PMRs and ask for those. We have those we can hand out if you're facing any issues that collect a little bit more than just the basics. Then I just wanted to point to RDMA verification. A lot of times people will bring the nodes up and they don't notice that RDMA failed to start. Just make sure your RDMA is working, because if everything's going back to TCP and that's a 1 gigabit network, it's not going to run too well. So it's always good to keep that on alert, whether you're using a user exit or you have a software product that's verifying and reviewing your MMFS logs for certain messages. It's good to keep in mind. So let's say you have a performance problem that's expel related. There is a Linux equivalent of like perf PMR. I don't know if any of you have heard of that. But usually that's the route that we go down for performance issues, gathering that data with that expel. User exit is great because you can see what's going on the system at the time of the failure. So we have that Linux LP CPU tool that comes from the LTC, and then of course AIX version. There are, again, the missed ping timeout, least recovery wait parameters. You can bump those up if you want to, but just keep in mind that these are going to have an effect on the cluster in terms of recovery and may make the cluster appear to be performing slowly. So you have a problem or performance delay in your network. Tuning these parameters in spectrum scale is not necessarily going to solve that problem. It's just going to make spectrum scale a little bit more loose in terms of whether it's going to kick out the node or not, and more accepting that problem is there. Then your jobs are going to notice it in terms of performance still. So at the end of this, really, I'm just pointing to some of the links. This presentation, I think, will be available to download for these. We have a change in our recommendation for VM min-free kbytes. We're now documenting in the FAQ that you should never have that higher than 2 gigabytes. In the past, we would say 5 to 6% available system memory, but now we are limiting that. I know this, a lot of times customers come in and they say, well, Red Hat or my other Linux support vendor says, no, don't do this. But there are a lot of cases where we see problems with the defaults from not having the memory available, especially during apply policy or heavy workload. So this will definitely help with preventing memory allocation shortages to spectrum scale. Performance tuning simplification, the worker threads. I really want to urge everybody to take a look at this if they haven't already. In terms of the ease of that tuning and configuration, this is really helpful. It doesn't cover everything that you can tune and that you'll see on that page, but the same information is available on that DeveloperWorks wiki page that Scott runs. And then lastly, real quick, since we're just about to run out of time here, let's say you have a problem now and you need to get to support and you don't want delays, right? The system's down and level 1 support at IBM says, I need a snap, I need you to send me data, or I won't be able to escalate it to level 2, or they're not going to be able to make progress until they have some data. These are some of the things that you can do to make Snap run and run quicker. So a couple of the new flags that we have is limit large files, and there's also the purge files flag. So all of this new data that's coming in from deadlock amelioration and the expel data you'll see in the temp directory adds up to quite a bit. And if you're running GPFS Snap across a huge cluster, a lot of nodes, it takes a long time for that file copy to occur. So if you're able to either limit that data to a certain number of days, then we recommend limiting that back down to the last 2 days if that's when the problem was. Or if you have ability to tell which nodes are relevant, get us the manager node, the cluster manager node in the case of an expel, and the 2 nodes that are involved, then limit it with the -n parameter. And those files, in terms of collecting the large dump files, will be, we're now keeping track of which ones we've collected. So the first time you run GPFS Snap, you're going to see everything collected. And the next time you run it, it remembers, I already collected those previous ones, so the next snap will be much smaller. But you might find that deadlock amelioration data from a couple of weeks ago is in there and is irrelevant to the problem that you're currently facing. So why do I want to delay the upload of all that data? So keep in mind of that. We're hoping to have a nice procedure that we're going to give to our level 1 support team to follow and recommend to customers who aren't aware of this. But for now, these are some things you can keep in mind when they're asking for that data. So here's limiting the nodes. I just encourage you to avoid the -z flag on GPFS Snap because it's going to lose all of the cluster-wide commands, cluster-wide aware commands that we see in the master snap portion of the data. Sometimes you have no option and you have to run that because those commands are failing and you want to be able to still gather the logs for us. So you can do that, but if at all possible, please avoid using that. I think I am running out of time here. The last thing I had on the GPFS Snap part here was the purge files. You don't want to see your file systems filling up, so you can use something like a cron daily to execute GPFS Snap purge files and delete all of those dumps. Make sure you're not keeping them around for too long. And here's just some quick internals on CCR for the experts in the room who used to like editing the MMS DRFS file directly. A lot of these files are now in the cluster CCR cluster configuration repository. This is just an example of just a generic spectrum scale only cluster. So you see the MMS DRFS files in there. And there's an ability to, these are internal commands, not officially documented too. So it's at your own risk, but you can list the files in the repository, the versions with flist, mmccr flist, mmccr fget. You can pull a file out, and then you can make changes to it and fput to get the file back into the repository and refresh the configuration across all the nodes in the cluster with an refresh and have those changes become apparent to the rest of the commands in the cluster. But another best practice around this is don't disable CCR if you're running protocols, because there's this huge list of other protocols configuration files that you have stored in CCR now that you will lose if you disable CCR. So try not to disable CCR if you're running a protocols environment. If you have a situation like that where you're running into a problem with a command, I would just recommend contacting support in those cases. So that's really it I had for the presentation. Thanks so much, everybody, for listening to the support view.